For problem 9, we are told that the average score on an IQ test is 100 with a standard deviation of 15. We want to also suppose that IQ scores are approximately normally distributed. Drawing a picture of the situation, we know that if something's approximately normal, that it is bell-shaped and symmetric, and its center value should be the same as the mean, in this case 100. Each of the jumps for the standard deviation then, which we should get approximately 3 of in here, going both up and down from the mean, should be 15 units. We want to know what proportion of all people have an IQ that is no more than 115. We can calculate this by first finding the z-score associated with the problem and then looking up that value on our applet. Remember that z is equal to our x value, or the problem value that we want to know about, in this case 115, minus the mean value for the distribution, mu, which in this case is 100, and then we divide that by the standard deviation for the population, which we also call sigma. In this problem, that would be 15. Calculating z, we end up getting z equals 115 minus 100 divided by 15, which will be equal to 1. If we then go over to our applet, we can use the values of the mean being 0 and the standard deviation of 1 because we've calculated our z-score, and we want to know the probability that a person will have an IQ that is no more than 115. No more than is another way of saying less than 115, or below. So we want to figure out the probability of being below, and our z-score was 1. Plugging that into our applet, we can see then that the probability would be 0.8413 if we round.